Express as partial fractions 2x squared plus 3x plus 6 over x plus 1, x squared plus 4. So let's start with that. We need to use the correct form for the linear factor and for the quadratic factor. So we have 2x squared plus 3x plus 6 over x plus 1, x squared plus 4, and that's going to be the same as using the correct form for the linear factor, a over x plus 1, and for the quadratic factor, bx plus c over x squared plus 4. Now what we want to do is go clear of fractions, so we're going to multiply right the way through by this denominator, and if we do that, we get 2x squared plus 3x plus 6 is going to be the same as a x squared plus 4 plus bx plus c x plus 1. Now we can start this by taking x equal to -1. If we do that, the left-hand side here becomes 2 take away 3 plus 6. On the right-hand side, we know that all of this is going to become 0. And so we have a multiplied by 1 plus 4, so 5a. So that is 5 equals 5a, and that means that a is equal to 1. I'm going to take x equals 0 now, because x is multiplying the b here, and that will get rid of b. So if it's 0, the left-hand side becomes 6. The right-hand side becomes 4a, and we know that a is 1. And then with the b being 0 and the x being 0, we're just left with c. And that tells us that c is equal to 2. And then I'm going to look at coefficients of x squared. So on the left-hand side, we get 2. On the right-hand side, we get a plus b. We know that a is equal to 1, so that tells us that b is 1. And therefore, what we get is 1 over x plus 1 plus x plus 2 over x squared plus 4. So if we now want to integrate from 0 to 2x squared plus 3x plus 6 over x plus 1, x squared plus 4, then using our partial fractions from above, we get the integral from 0 to 2 of 1 over x plus 1. And remember, we then had x plus 2 over x squared plus 4. I'm just going to split that into x over x squared plus 4 plus 2 over x squared plus 4. So that's going to give us natural log of x plus 1. And then with this next part being a half of 2x over x squared plus 4, and doing that then makes 2x is the differential of the x squared plus 4. So we're going to have a half ln mod x squared plus 4. We don't really need the mod there because x squared plus 4 must be positive. And then this one over here, well, if you integrate 1 over x squared plus 4, that becomes a half the inverse tan of x over 2. So with the 2 here, we're just going to get the inverse tan of x over 2, and that is from 0 to 2. So, using the top limit of 2, we get ln 3 plus a half ln 8 plus the inverse tan of 1. With the bottom limit, we get ln 1 plus a half ln 4 plus the inverse tan of 0. This is 0. This is 0. So that is ln 3 plus a half ln 8. The inverse tan of 1 is pi by 4. And then we have a half ln 4. And we can use the log law to put these two together. So we have ln 3 plus a half ln 2 plus pi by 4. And then we can get it into the required form. So this is ln 3 times, for this one we can put the half inside and get root 2, so that's root 2. And then we've got the plus pi by 4, so it's ln 3 root 2 plus pi by 4.